All right, so the final answer for that example was supposed to be -1,310,720. We are going to be skipping example D as there is a typo, so you can flip to the back of your worksheet, and we're continuing with the 11.3 notes, geometric sequences and series. So we're going to continue with our objective of writing a rule for the nth term. Remember that in disguise means create a formula. And remember, to create a formula, I need term 1 and R. So that's my goal, is to find those two things. It's going to be a little bit different every time depending on what information they gave us. This time, I know that term 3 is 5. I know that the common ratio is 2. So what I need to do is find a 1. Again, we can use our formula in many different ways. So, because I can, in this situation, I'll say that term 3 represents term n. So n is 3. R, we know, is 2. And then, so I put the number of the term, which is term 3, in for n, and then whatever the actual result of term 3 is, or whatever the actual number is for term 3, goes in for term n. So the 5 goes there and the 3 goes in for n. That's a little confusing. All right, so I've got 5 equals a1 times 2 squared, which is a1 times 4, divide by 4, and it looks like term 1 is 5/4. Okay, so I'm ready to write my sequence rule. So I'm going to plug in A1, I'm going to plug in R, and that's it. For geometric, once you plugged it in, you're done. Why don't you pause the video and please try part B on your own, and when you're done, unpause and I'll have the answer revealed. All right, you should have gotten A1 is 1/9, and so my rule for the nth term, or my formula, ends up being term n equals 1/9 times 3 to the n minus 1 power. Once again, if you have any questions on that or things you want to ask me in class tomorrow, make sure you write it down. Write down what your questions are, put a star by it, whatever you need to do to remember what you want to ask me. All right, so now we're going to go into the most complicated type of problem for finding a rule for the nth term, and this is when I'm just given two of the terms. I'm not given A1 and I'm not given R, so I actually have to find both of them. Here's what we'll do. You always want to find R first, because I'm actually given enough information to use my R equals the m minus nth root of term m divided by term n. And remember that this m and n are the numbers of the term, so I would put 5 minus 2 here, and then the terms are the actual values that are in that spot. So I am going to find right now the cubed root, and then negative 1,215 divided by 45 is negative 27, so the cubed root of negative 27 is negative 3. So my R right now is negative 3. Once I have R, I have enough information to find term 1. And now this is like what I just did in example 4. So this really just has one extra step, and that is we have to find R by ourselves. At this point, it's just like what we did in example 4. Now I have two different terms I could potentially use, like we did in section 11.2. Just pick whichever one looks easier to you. So A sub 2 looks like it has smaller numbers, so I'm going to use term 2 as term n, which means n is equal to 2, and term n, which is term 2, is 45. So if I look at my formula here, I'm going to put 45 in right here for term n. A1 stays A1 because that's the variable I'm trying to find. R is negative 3, we just found that, and then n is the term I'm using. So right now I'm using term 2 as term n, so I put in n 2 for n. I am going to go ahead and solve it, and actually negative 3 to the first power is just negative 3, so divide that negative 3 off of there, and term 1 this time is negative 15. Once I have term 1 and r, I am ready to create my formula rule. To create my formula rule, plug in term 1, plug in r, and there I go. That's my final answer. Okay, so once again, I'll do part of this first one with you. So once again, our first step is to find r. Remember that the term that is later in the sequence always is the m, and the term that's earlier in the sequence is always the n. But once again, the little index, the little numbers there are the numbers for the root. And the big numbers go underneath. So right now I'm looking for the fourth root of 256, which ends up being 4. Alright, I want you to try to see if you can find A1 and try to see if you can find the formula rule. Go ahead and pause the video, and when you unpause, I'll have the answers showing. Good luck! Alright, so we had found previously that r is 4 for this example, and then I want to show you that it doesn't matter if you chose to use term 2 in order to find term 1, or if you chose term 6 in order to find term 1. Either way, when you plug them in, if you plugged it in correctly, you should get the same answer for term 1. So it doesn't matter which one you pick, but you should have gotten term 1 is -1. And now I'm going to plug that in and r, and technically, you don't need to have -1 times something. I can just say negative that something. So there I go. A sub n equals negative, and then 4 to the n minus 1 power. At this time, we're going to start talking about the sum formula and adding together my geometric series. So just a review from what we did on the front page, the geometric series, or the sum formula, was S sub n equals A1 and then 1 minus r to the nth power divided by 1 minus r. So that's a formula we're going to use to find the sum of the first n terms. Starting with example 6. So check it out. Consider the geometric series 1 plus 5 plus 25 plus 125 and so on. I want to find the sum of the first 10 terms. Okay, so whatever you're trying to find, so in this case 10 terms, that means n is 10. And then notice, this formula actually, it looks more complicated, but it's a little faster actually than the arithmetic series formula, because we don't have to find term n. All I need is term 1, r, and n. See this? I need term 1, I need r, and I need n. So I need those three things. I already found n. Term 1, well, that's just the first term in the sequence, or the series, so that right now that's 1. And then I need to find r. r is the common ratio. So what's happening? So again, you can always take a term divided by the previous term. So in this situation, if I just know a term right next to the next term, I can just divide them. I don't have to use the formula because they're right next to each other anyways, so I don't need to take a root of it. And that means I am multiplying by 5 each time. Okay, I'm just going to plug in my numbers into my formula. So term 1 is 1, r is 5, n is 10. Okay, check that out. And now I would just want to tell you that the #1 mistake that students make on these is the wrong calculator entry. So if you're someone that likes to try to type it all up all at once, you're going to need parentheses. And I will show you, this is to ensure that I do not make a mistake. This is how I usually type it in. I usually type in the top. So there it is. There's the top, 1 minus 5 to the 10th power. I usually then hit enter. And then I divide by, and then I put the bottom in parentheses. And then I would times by the number out front. So in this situation it's a 1, so it doesn't really do anything, but I usually times by this number out front at the very end. And so I end up with an answer of 2,441,406. And these are, again, going to be really big because the geometric series and sequences get big really fast. So you're going to have big numbers. I would recommend that you try typing it in just to make sure that you can get the correct answer for that one. Okay, so here's another example of the same type. So again, in order to find my sum, I need to know n, I need to know term 1, and I need to know r. So n is how many terms I'm adding together. This time I'm adding together 15. Term 1 is the first term in the sequence, and r, sometimes you can tell just by looking at it, so look at this. Or if I try dividing, it looks like every time it's multiplied by -2. So the sum of the first 15 terms is term 1, which again is 1. It's not always going to be 1, just both these examples that ended up happening. And then I got 1 subtract -2 to the 15th power. Make sure you put that in parentheses, because if that is an even power, that will make a big difference. And then 1 minus -2 on bottom. So notice that my 3 things I plugged in are there. Now, why don't you right now see if you can type this into your calculator correctly. So pause the video quick and try typing it into your calculator. You should get 10,923. So pause and give it a try. If you have unpaused, we're going to now flip to the back page, and I've got a few more examples to show you. We're going to now talk about what to do when I'm given sigma notation, or the summation notation. So there's a few different things that we're going to do with this summation notation. For some of the problems, you're going to actually have to write out the series, which means we're going to find every term and then write them all out and then add it up. And then some of them we're just going to have to find the sum. So there's 2 different types of examples here. Make sure that you watch one of each type at least. Alright, so to write the series, they actually want me to find every term and write it out. And we're going to be relatively nice to you in that. Notice that this is only going from term 1 all the way up to term 8. So there's 8 terms I need to find essentially. So I'm going to find term 1, term 2, term 3, and so on. And every time I'm finding a term, I am going to plug in whatever term number I've got here for I right there. So for this first one, 1 minus 1 is a power of 0. So -2 to the 0 power is 1 times 4 is 4. Remember, you always do exponents before you multiply. So I would always do this part right here first, then multiply by 4. Alright, so I'm going to keep going here. So now to find term 2, and I'm writing them all out. You can do some of this just in your calculator, but again, notice I need to do, either I can just type it all up here, or I need to do -2 to the first power first, then times by the 4. So again, times by the 4 at the end, or just type it all into your calculator. But I end up with a -8. So technically I should just write subtract 8. And right here is me writing out what my series looks like. Alright, I'm going to keep going. So term 3, I'm going to plug in a 3 for n. And I end up with 3 minus 1 for the power, which is 2. So -2 squared, which is 4. 4 times 4 is 16. And now I'm just going to keep going in this vein. I'm not going to say as much now, but every single time I'm plugging in my term number in here for I, and then evaluating, remembering to do my power first, then multiply by 4. So now -2 to the 3rd power times 4, so that's -32. And I need to keep going until I get to term 8, because it's going from term 1 to term 8. So every single time, and again, your choice, you don't have to write all of these out if you are understanding what's going on here. And for the rest of them, I end up with 64, -128, 256, and -512. So me writing this out right here, this is me finding the series. So that's my answer for this part of the question. Okay, that what I highlighted in blue is my answer to that part of the question, and now I need to find the sum. Well, I could use the formula, but since we already just found all of the terms by hand, we might as well just add them all up. So 4 minus 8 plus 16 minus 32 plus 64 minus 128 plus 256 minus 512, and I am ending up with negative 340. So the sum is negative 340. All right, let's try another one. So again, this time I'm only going up to term 5, so that one will be a little nicer. So I'm going to write out the series, and then I'm going to find the sum. And so every single time I am plugging in my n value for the I, or I guess my I value for the I, since my variable is I this time. And I'm writing down that 1 in front, but I don't really need to, since that's not going to affect anything. And you do not have to write all of this down if you're understanding what's going on. But see, every time I'm plugging in whatever the term number is for the variable, which in this case is I, but it could be anything. It could be n, it could be k. Those are the ones that are most commonly used. When I go through and find this, I end up with 1 plus negative 3 plus 9 plus negative 27 plus 81. So that is my series written out. And when I add those all together, my sum is 61. All right, now we do not have to write out the series. We're going to find the sum only. So if I'm going to find the sum only, it's really to my advantage to try to use my sum formula. That's going to save us some time. So here's what I need to figure out, though. I need to figure out term 1, I need to figure out r, and I need to figure out n. And now, magically, this is the awesome thing about geometric series and sequences. They're always going to follow this format, right? So you know whatever number is in parentheses that has the power, that's always going to be r. And whichever number is in front of the parentheses is going to be term 1. And, you know, if it is a 1 in front, they don't ever write it. So right now, if there's nothing in front, it means term 1 is 1. So let's just go through that really quick. So look at example F. Again, A1 is in front, R is in the parentheses every time because it matches this formula. They're all written in geometric form. Anyways, I also need to find n. So I need to think about how many terms are going to be added together here. I'm going from term 1 all the way up to term 6. So that's going to be 6 terms total. So n is 6. And once I've found all those things, I can now plug it in to my formula. And as long as I use correct parentheses with my calculator entry here, I can end up with the correct answer. So let's give it a shot. So on top, I got 1 minus 0.2 to the 6th power. And then I'm dividing by 1 minus 0.2. And then it's times 1 out in front. And I end up with 1.24992. If it's a decimal that terminates, that has an ending value, just write all the digits. I don't know. Unless it specifically says to round to a certain place. And sometimes it might. All right, I want to show you what we're going to do if I am not starting at 1. So let me tell you something kind of interesting. If I am not starting at 1, when I use my formula, I'm actually going to use term 0 right here instead, which is kind of a mind trick, but see how the rest of these all had I equals 1 on bottom and this one has I equals 0? So this is really actually not term 1 right now. That is actually term 0, which is kind of weird. But if you don't trust that, if you're not really sure what I mean, I can always just plug in a 0 for here, and I do end up with 0.01. R is the thing in the parentheses, and n is how many terms there are. And now think about it. Instead of going from 1 to 6, I'm now going from 0 to 6. So there's actually 7 things there. So n is 7 this time. So I'm finding the sum of the first 7 terms. I am plugging in my formula. And by the way, this is the first time that we've actually had an interesting problem with a number in front for term 1. So let's type this up and make sure you can do this correctly. So once again, you don't have to do it this way, okay? If you prefer to just type it all up right away, that's totally fine. I like to do, again, I like to do what's on top of the fraction first. 1 minus 3 to the 7th. And then I like to divide by what's on bottom. And if it's something you know, I mean, take it, you don't have to type it all into your calculator. For example, 1 minus 3 is negative 2, so there I go. And then at the end, multiply by the number in front. Again, you may have a slightly different way of typing that into your calculator. As long as you get the correct answer, I am happy with that. So the sum of the first 7 terms this time is 10.93. Please pause the video and try part G on your own, and when you unpause, I'll have the answers showing. Alright, so just comment, this one again had the I equals 0 on bottom, so there's actually 5 terms. So if you got the incorrect answer, that could have been your mistake, but this ended up being a long decimal that did not terminate, so I decided to round it this time. We still have examples 7 and 8 to go, but we're going to do those in class tomorrow. So thanks for listening, and we'll talk to you again soon.